Melting point.
Melting point would be, let's make it F. And it would be very similar to A. It'd be temperature at which a solid melts. What's that? Yep.
So what is it? BD blank ACD.
What's not my letters?
B.
B,
Okay, now I
D,
have to actually do it because I'm not having cooperation.
D.
F, A, C, E.
AC.
ACE?
Yeah.
Congratulations. You remember chemistry.
Alright. Highest to lowest. Basically, I want you to relate. Remember, we put all these things. Here's melting point right here. We had melting point, viscosity, surface tension, boiling point, evaporation. Okay? It's not wise to memorize the chart as in for this end.
Just drop it.
Okay, it's not, well, what I'm saying, it's not wise to finish up memorize all that stuff because as long as you understand the concept, you should have this one, and it's not hard. Is this hard to memorize? As long as you know the order, you can piece this together.
Wait, is
Basic-
ionic supposed to be below metallic?
No, you can switch them either way.
Oh.
It's case in point.
It's the same thing.
You could, yeah, you could say it matters from substance to
So they're
substance.
50-50.
What's a network
You're
again?
basically on the same level.
Right,
What's a network?
but you could compare weird things like tungsten and
Oh,
mercury.
right.
They're totally different volume. Okay, so
It's
you have to analyze all these and see how they actually fall on this continuum. So that means you have to draw all these structures. I know a lot of us probably already did that. What do I have for H3?
Trigonal pyramids.
Okay, what's my stuff though?
H-
Just H bonds, London polar.
Next one.
Next one turns out to be London,
Next one.
ionic,
Next
and
one.
then London polar. So obviously, ionic's going to be the strongest.
Highest.
All right, so it's gonna start at 1, highest to lowest.
And then H bonds is 2, polars 3, and 1.
There you go.
Wait, why is K2O ionic?
It's the metal, non-metal. Potassium's over there. Alkaline.
Oh.
Because there's the number under.
So, let's just be honest here. This could have been on our last quiz or our last exam, as in just this stuff. Analyzing each chemical and tell me what they are.
Yeah.
That's old stuff.
Yeah.
The only thing new is just putting them in order on the continuum. You know, so all you gotta do is, at first, what makes this hard, let's talk about this number 2. What makes this more difficult is that, you know, it's 4 times as hard because you have to draw out, I'm not just asking, analyze NH3, I'm saying you have to analyze them all at once and then put them in order. So far, are we on board? Not as bad as the way you were freaking out before?
No, I just, in my notes, my chart looks a little different, but I like the one that you have on the board right now better, so.
It was basically the same though, wasn't it?
Mine,
just-
like, I don't know.
I just forgot.
Oh, I know, because I said this one was London polar, this one was H-bonds London polar.
Sorry for
Well,
freaking
it
out.
was just
I
that mine, like,
mean
didn't
to.
say, like, you can look if you want, but it just, like, it said, mine is, like, overface, something tension, I can't read my handwriting.
Right, surface tension, viscosity, evaporation, boiling point, melting point, all those.
Yeah, and then it says, like, strong, slower, and then
Right, and
high, and I don't get that.
well, here's what I'm saying, Shane. Like I said, the main thing you have to know is that the bottom's weak and the top is strong. And then when it comes to things like surface tension, you should be able to piece together which end is what. Right? If you have stronger attraction, you have a stronger surface tension. You don't flow as well. Harder to melt, harder to boil.
I guess, like, yeah, if you have a low viscosity, you should know that it's, like,
Weak.
easier to evaporate.
Right, exactly. That's what I'm saying. That all those are related. It's not worth memorizing. It's better just to understand what's going on, and then that unlocks that whole rest of the table. That's my goal for you. Yes.
Okay, so if you know how you say ionic and metallic are like the same thing, so if you were ranking them and they were
I won't have you compare ionic and metallic in the same one.
Okay.
I know. Like if I put this in here, it's up there, but let's say I just put iron by itself. Yeah, I can't do that.
Yeah. Okay.
Good question, though. It's a real good question. Okay. What would be an appropriate compound to dissolve NaDr? Yes, sir.
I said H2O because you automatically know it's H bonds, and H bonds would be closer to NABR with
So you're kind of thinking along the lines of this?
Yeah.
Okay, and these ones were London and London.
Wait, I don't get that.
And even though it's London, can only be we're in Asia.
So what he's saying is, here's my NABR. First of all, let's just say that you always have So you're saying this is ionic in beaker A. If you're going to mix the two beakers, one in this class again. Okay, you wouldn't pick one down here because
Did you ever do ionic in London?
I don't know if any that work actually.
What would you give us like a question like that? Well, that actually wouldn't, because then all three of them would have to be.
What if there was any type like what would be
But
the
you would
best
give us
one?
more information.
I would say this is that's all I'm looking for. So I'm not trying to spruce it up any more than that. What about my next one here? To be BF3. What's my MS? Just London. Trigonoplanar. You said polar, didn't you? F4. What's that? London polar. It's just London.
Don't you know?
Let's finish it up anyway.
The SIF4.
London.
Oh, so that's how.
Right here, since BF3, so this is going to be my SIF4. The other ones are up in this class.
Why not?
Typically,
Oh, is it a trigonal pyramid?
is it a seesaw? Yeah, 4. It's a seesaw. It's 4-1.
Alright.
This one. Yeah, 4. How many C's? Can I just write the 3 C's? This is propane, which had 3 C's. And 1, 2, 3, 4, 5, 6, 7.
Just write 9.
I'm not drawing the H's because it takes too long. I don't want to waste time.
You should.
Okay, who thinks they have this one? Go for it.
Wait.
What are you supposed to do?
The amount of
How about you? I question. How do you account for the fact?
I
the
still
amount
don't
of
get it.
carbons.
Oh,
I think I know.
go for it.
Wouldn't it be H2O? Because you just.
Yeah, this one's a gas and this one's a solid.
You're just supposed to state the stall.
This isn't making a solution, though. What are we talking about here?
No.
Read it again. All I'm saying, propane's a gas, nonane is a liquid.
But
Done.
okay, so what was
It's
this
so
thing
easy.
on this tube?
Well, don't look at that.